So now let us look into the actual model, real model, that is the TCP forward slash IP reference model. So let us now turn from the OSI, that is Open System Interconnection reference model, to the reference model used in the grandparent of all wide area computer networks, that is ARPANET. So and its successor, the World Wide Internet. So the ARPANET was a research network sponsored by DoD, that is US Department of Defense. It eventually connected hundreds of universities and government installations using leased telephone lines. When satellite and radio networks were added later, the existing protocols had trouble interworking with them. So a new reference architecture was needed. So thus, from nearly the beginning, the ability to connect multiple networks in a seamless way was one of the major design goals. So the architecture later became known as the TCP forward slash IP reference model after its two primary protocols. Based on its primary, it was named after their two primary protocols, that is TCP forward slash IP reference model. So it was first described by Cerf and Cahan in 1974 and later refined and defined as a standard in the internet community by Braden at 1989. So the design philosophy behind the model is discussed by Clark in 1988. So and then it was given the DoD, that's defense of uh, mm, and then Department of Defense of United States of America's worry that some of its precious hosts, routers and inter-network gateways might get blown to the pieces at a moment's notice by an attack from the Soviet Union. So another major goal was that the network be able to survive loss of subnet hardware without existing conversations being broken off completely. So, in other words, the Department of Defense United States of America's Department of Defense wanted connections to remain intact as long as the source and destination machines were functioning, even if some of machines or transmission lines in between were suddenly put out of operation. So furthermore, since application with divergent requirements were envisioned, ranging from transferring files to real-time speech transmission, a flexible architecture was needed. So these are the fundamental reasons that led to bring this new architecture, new reference model, that is TCP IP reference model by ARPANET. And it's not just ARPANET, there are a lot of students and colleges has worked with this. So we know an ideal model is OSI. It consists of 7 layers: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. So this is an ideal model, ideal reference model. OSI is an ideal reference model. So now what is the actual reference model that is made is TCP forward slash IP. This is the actual reference model. So how many layers it will consist of? Let us see. Let us see. Application layer does exist. Oh, so what is application layer? Here, the application layer. So the TCP IP model does not have session or presentation layer. So no need for them was perceived. Instead, applications simply include any session and presentations functions that they require. So experience with OSI model has proven the view correct. So these layers are of little use to most applications. On top of the transport layers, on top of the transport layer is the application layer. So it contains all the higher level protocols. It consists of the early one included virtual terminal protocol, that is telnet. Telnet, even though till they use this telnet protocol, and then FTP, that is file transfer protocol, even now we use it. Then SMTP, that is electronic mail protocol, and many other protocols have been added to this over the years. And it also includes domain naming system, DNS protocol, for mapping host names onto their network addresses. And then HTTP, the protocol for fetching pages on the world wide web. And RTP, the protocol for delivering real-time media such as voice or movies. So most of the protocols has been included in application layer only, and the presentation layer and then session layer has been completely eliminated. It does not have presentation and session layer. So then we'll have the transport layer. So the layer above the internet layer in the TCP or IP model is is usually called the transport layer. It is designed to allow peer entities on the source and then and destination hosts to carry on a conversation just as in the OSI transport layer. So two end-to-end transport protocols have been defined here. The first one is TCP. TCP is Transmission Control Protocol. TCP is a transmission control protocol, is a reliable connection oriented protocol. It's not the connection less, it's a connection oriented protocol, and that too it's reliable. That means it will provide an acknowledgement that the receiver has received the data packet that we have sent. So it's a reliable connection oriented protocol that allows a byte stream originating on one mission to be delivered without receiving uh, without error on any other mission in the internet. So it segments the incoming byte stream into discrete messages and passes each one onto the internet layer at the destination. The receiving TCP process reassembles the received messages into the output stream, and TCP also handles flow control to make sure a fast sender cannot swamp a slow receiver with more messages than it can handle. So this is one protocol that is widely used. However, there is a second protocol in this layer, that is UDP. This is user datagram protocol. Of course, this is unreliable. One is reliable and other one is reliable. One has their own benefits, and we have discussed the uh, positives and negatives of these services before only. So UDP is a user datagram protocol. It is an unreliable. So it's a connection less protocol for applications that do not want TCP's sequencing or flow control and wish to provide their own. So it's also widely used for one shot client server type request reply queries and applications in which prompt delivery is more important than accurate delivery, such as transmitting speech or video. The relation of IP, TCP, and UDP. These are all IPs, Internet Protocol. TCP is the Transmission Control Protocol, and UDP is the User Datagram Protocol. All can be seen in your screen exactly on top of your in front of your eyes. So since the model was developed, IP has been implemented on many other networks. So then the next layer in pipeline is the internet layer. The internet layer is the linchpin that holds the whole architecture together. So it is shown in the infograph as corresponding roughly to the OSI network layer. So its job is to permit its job is to permit hosts to inject packets into any network and have them travel independently to the destination, potentially on a different network. So they may even arrive in a completely different order than they were sent, in which case it's the job of the higher layer to rearrange them if any order delivery is desired. So let's go for the analogy of the TCP IP proto IP model with the mail system analogy. So the analogy here is with the mail system. It begins with writing a sequence of letters. So that is our application layer. So now a person can drop a sequence of international letters into a mailbox in one country, and it will and with a little luck most of them will be delivered to the correct address in the destination country. So drop these letters into a mailbox in India, and we are hoping that it's going to be delivered into United States of America or whichever country destination country you are expecting to be delivered. So then that's our transport layer. So now the letters will probably travel through one or more international mail gateways. That's what the internet is. We do not know exactly through which way it goes. It doesn't matter. It can take a flight, it can take waterways, it can take any way. It doesn't matter. So that's why the letter will probably travel through one or more international mail gateways along the way, but this is transparent to the user. So furthermore, each country, that's each network has its own stamps, preferred envelope sizes, and delivery rules is hidden from the users. So here the internet layer defines an official packet format, and protocol is called IP, that is Internet Protocol. So Internet Protocol plus a companion protocol called ICMP, Internet Control Message Protocol, that helps it function. So the job of the internet layer is to deliver IP packets where they are supposed to go. So packet routing is clearly a major issue here, as is congestion. So though IP has not proven effective at avoiding congestion. And then finally we'll have the physical layer. So through the physical layer it's going to be but that physical layer also will be taken care by the internet only. So then the last layer, the fourth layer of This, you can see this internet layer has two protocols, that is IP and then ICMP. IP is internet protocol and then ICMP is internet control message protocol. So, and finally what we have is the link layer or the physical layer. So all these requirements led to the choice of all these requirements led to the choice of packet switching network based on the connectionless layer that runs across different networks. So the lowest layer in the model is the link layer, so that we are missing the link layer. And the link layer describes what a link such as a serial lines with the classic Ethernet must do to meet the needs of this connection less internet layer. It is not really a layer at all in the normal sense of the term, but rather an interface between hosts and transmission links. So early material on the TCP or IP model has little to say about it. So if you see it, these are the total four layers that are available in TCP IP actual real reference model, and then each layer has a different protocol. In application layer we have HTTP, SMTP, RTP, DNS, and then for link layer we have DSL, SONET, 802.11, Ethernet. These are the basically standards that we have seen. Ethernet standard 802.8 and 802.11 is wireless, that's Wi-Fi, and 802.3 is some other one. So we have DSL, that is also related to the connection only, internet connection, and then SONET. So these are the different protocols that are specific that are related to the each layer of the TCP or IP. And you can see the TCP or IP, the mail system analogy also here.